All right, in this video, we're going to cover how to do a one proportion confidence interval from chapter 19. We're going to look at number 24 on page 448. And they tell us that in 2004, ACT reported that 74% of 1,644 randomly selected college freshmen returned to college the next year. Estimate the national freshman to sophomore retention rate. So for confidence intervals, there's 3 steps. First, you need to check your conditions because I have a qualitative variable here. I'm going to do what I did in chapter 18 with proportions, and I'm going to check the random condition. Now, in the stem of the problem, they said it was randomly selected, so I can just say it was stated random. We also need to check our independence assumption. It's reasonable to assume that one student score or one student returning to college the next year wouldn't impact the next. So we're just going to state that. Assume one student's retention doesn't affect another's. We need our 10% condition, which basically in general states that our sample is less than 10% of the population. So here, 1,644 is less than 10% of all college freshmen, which is a very reasonable claim. And finally, the one that's going to change based on if it's quantitative data or qualitative data is our success failure condition. If you remember back in chapter 18, when we dealt with means, we checked the large enough condition. So we need to have at least 10 successes and 10 failures, so NP needs to be greater than or equal to 10. Well, our sample size is 1,644 times the 0.74, our sample proportion. And our N times Q is 1,644 times the 0.26. Both of these numbers, I don't have a calculator right now, but I know these are greater than or equal to 10, so that checks. And then we're going to do what we did in chapter 18. We need a transition statement before we get to the mechanics of creating this confidence interval. So we're going to say our conditions have been met. We're going to use a normal model for A, and you have to name the inference procedure to earn credit on the AP exam, and this is where we're going to do that. This is called a one proportion Z interval. Why? Well, one proportion because we have one proportion, Z because we're using the normal model, and interval because we're doing a confidence interval. Okay, so that's the first step, and I should have labeled, let's do that right now. The first step for confidence intervals is going to be conditions. All confidence intervals, you're going to start with that first step, conditions. Okay, so let me open another page here. Okay, the second thing that we're going to do for a confidence interval, now that we've checked our conditions, is going to be the mechanics. And this is where we actually do the calculations. So part A is done. We verified the conditions, they were met, so now we can construct this confidence interval. So we're working on part B right now. All right, so we know for a one proportion confidence interval, you're going to have the format of p hat plus or minus your critical z value times your standard error of p hat. And as you saw in the other videos, we need to use standard error instead of standard deviation because we don't know the true proportion. So we're estimating it using the sample proportion p hat. So p hat is 74. P hat is 0.74 plus or minus. Our critical value for 98% confidence, well, if we have a normal model here, as you saw in the videos last week. So if you have 98% of the data in the middle here, you're going to have 2% left in the tails, so 1% in each. So on the calculator, I can do inverse norm of 0.01. And that's going to give me a value of approximately 2.326. So that's going to be my critical value for this confidence interval. So 2.326 times my standard error, which is going to be my sample proportion, 0.74, p hat times q hat divided by my sample size. All right. Now remember, this part here, this is commonly referred to as your margin of error. So that's our margin of error. Our confidence interval, remember, is going to be centered at p hat always. It's centered at your sample proportion. So at this point, I can plug this into the calculator under stat test one proportion z interval. Okay, now that I got my calculator, we're going to go to stat, arrow over to tests, and you're going to scroll through the menu and find one proportion z interval. It's under part A. So you're going to click on that, one proportion z interval. Now, what you're going to do in X, you need to enter the number of successes. Well, that's the same thing that you did when you did n times p. So you have 0.74 times 1,644, which gives you 1,216.56. But this is critically important. This must be an integer value in the calculator. So because they round the sample proportion to 0.74, I need to round this to the nearest integer. So I need to replace this in the calculator with 1,217. For n, I'm going to put my sample size, which is 1,644. For the C level, we're going to put the confidence level. Well, we're asked to do a 98% confidence interval, so I'm going to put 0.98. You can also put 98. Or I apologize, you cannot put 98. You can only put it as a decimal equivalent. So we're going to put 0.98. Actually, I take that back. Either one will work. You can put 0.98 or 98. Either one will get you the correct confidence interval. Go ahead and hit calculate. And this is what you should get. We have a confidence interval of 0.71511, comma, 0.76543. Okay? So this represents the mechanics. All that I need to see as far as earning essentially correct on this is you substituting into the formula this part here and then your final confidence interval. That's it. I don't need to see this work from the calculator. If you forget how to do it in the calculator, you can do this out by hand, multiply these two, add that value to 0.74 to get the upper bound, subtract that value from 0.74, that margin of error, to get the lower bound. Okay, so that's the second step of doing a confidence interval, and that's what part B asked. Construct the confidence interval. We've done that. Now, if we were to do a 90% confidence interval here instead of 98, that means we would be less confident, so our interval would be narrower. If we went to 99% confidence, we would have a wider confidence interval. Because our critical value is getting larger, we're having a greater margin of error. Just some things to think about there. Okay. So let's take a look at part C. All right. In part C, it says interpret your interval. So the third and final step of a confidence interval is going to be your conclusion. And once we move into chapter 20 and we start talking about a hypothesis test, you're going to notice a lot of similarities. It's just going to be a 4-step process where 3 of the steps are similar to confidence intervals with conditions, mechanics, conclusions. So you want to get in the habit of writing this down and setting that format now. So for a conclusion, we need to say we're 98% confident of what? Well, we're 98% confident that the true P is within our confidence interval, within our lower bound and our upper bound. So what does that mean? That means we are 98% confident that the true proportion of college freshmen who return to school the next year is between, and what I'm talking about when I'm saying the true proportion here is P, but we don't know what P is. That's why we did a confidence interval in the first place, to get an estimate. And we're going to see in part D what 98% confidence means. So is between, according to our confidence interval, 71.5% and 76.5%. Okay. So we're 98% confident that the true proportion of college freshmen who return to school the next year is between 71.5% and 76.5%. Now keep in mind, this is not a probability. It's not a probability. It's not saying we're 98, the probability of it being in there is 0.98. That's not what we're saying. We're 98% confident that we've captured P, the true proportion, in our confidence interval. So now into part D, it says explain what 98% confidence means. And this is where you need to start thinking about things a little bit differently. So let's open a new window and take a look at that. Okay, so there's a fine line between understanding the conclusion of a confidence interval and understanding what 98% confidence means. The difference is, as Michael talked about in the previous video that you guys watched, was 98% confidence is if you take many random samples of the same size, about 98% of them are going to create confidence intervals that capture P. And you guys saw this. He had this line that represented P, and different people took confidence intervals, and about 98% of these intervals created from the many random samples actually contained P. So let's put that in context here for this question. Okay, so for us, what does that mean? So that means in many random samples, of size 1,644 has to be the same size as the sample we took. 98% of the samples will produce confidence intervals, and that's what you saw on that picture that I was just drawing. That contain the true proportion, or P. Now we're just putting that into context. 98% of the samples will produce confidence intervals that contain the true proportion of college freshmen who return to school the next year. Okay, so you can see in part D here explaining what confidence means, and then going back to what we did in part C, where we explained the conclusion for the confidence interval. There's subtle differences here that you need to make sure that you understand the difference between. So in our next video, we'll take a look at hypothesis tests as we move into chapter 20.